In this video, we're going to dive into Hello Ethernaut, the very first challenge in OpenZeppelin's Ethernaut CTF series. This room is designed to introduce you to smart contract security and the basics of interacting with Ethereum contracts. And we're going to use Foundry to script our exploits. So Foundry is a toolkit that the seasoned security researchers use in order to write scripts and deploy their contracts. So we're going to use Foundry instead of the basic browser console way of doing this CTF. So here's the thing: if you're new to blockchain hacking or want to sharpen your Solidity skills, this is a perfect starting point. And with that said, let's get into it. So right here, I'm in my virtual machine here. I'll just go back to my normal machine over here. And to access the Ethernaut CTF series, just go into ethernaut.openzeppelin.com. So one thing I need to make clear: for you to access these CTFs, you need to make sure that you have a MetaMask account and a MetaMask wallet. And as you can see here, it's asking for MetaMask account, and it's saying MetaMask account not connected. So it says here, to begin your adventure, connect your MetaMask wallet. Our game interacts directly with Ethernaut on-chain contracts, which means that your actions in the game are recorded on the blockchain. By linking your MetaMask account, you can securely engage with these smart contracts, allowing you to solve challenges and progress in the game. So I'm just going to click here, connect, because I have my MetaMask wallet here. If you don't have MetaMask, I'll leave a link down in the description that will link you to a video that shows you how to install MetaMask. So let's just get started. If you don't have the MetaMask, pause the video and go install it and install the extension and connect your wallet. So let's get started. I'm going to click connect here. So let me just first give it my password, my MetaMask account password. So after this, is going to prompt me to connect my MetaMask account to this. So it's loading. And here we are. This is the Ethernaut, OpenZeppelin's Ethernaut site for these CTFs. And as you can see, there are up to 33 challenges. So we are going to start with the first one, which is called Hello Ethernaut. So here's the CTF right here. So first it tells you to set up your MetaMask, which we've gone through. Then it tells you to open the browser's console. So you can just do this by doing Ctrl-Shift-I. Then here we have our console. Here we have this output in the console, Hello Ethernaut. Then we get the instance address, then the level address right here. Then let's proceed here. You should see a few messages from the game. One of them should state your player's address, which is our wallet address. This will be important during the game. You can always see your player address by entering the following command, player. So you can just try and do that. Enter player. Then here we have our MetaMask wallet address. Is the same thing with if I click MetaMask here, it will just show me my account address over here. You can see it starts with 23, and as you can see here, the same thing here. So keep an eye out for warnings and errors, since they could provide important information during gameplay. So number 3, here we have use the console helpers. You can also see your current Ether balance by tapping get balance of the player. So you can just do get balance, each tab there, then of the player. Okay, so this makes a call and it returns a promise. So in order to go around this, we can just click here and you can see the balance here, but this is quite annoying, so we'll just do await. Then now we do the get balance, then player, because this makes a call to the transaction. So yeah, now this gives us the right information promptly. So then he tells you, yeah, you can use the await get balance. Then you can also use help. So I'll just do help here. And here we have some more information. Here we have what you can the keywords you can use. You can use player to show the their current address, Ethernaut to show the game's contract, the level. We have all these keywords over here. So we'll just continue here, and right here we can see enter the following number 4, the Ethernaut contract. Enter the following command in the console. So we can just do Ethernaut. As you can see here, it gives us all the information about this contract. We have all the information here. We also have the ABI, the application binary interface over here. We'll get to that here. Number 5, interact with the ABI. So Ethernaut is a truthful contract object that wraps the Ethernaut.sol contract that has been deployed to the blockchain. Among other things, the contract's ABI exposes all of the Ethernaut's public methods such as owner. Type the following command, for example. So we can just go through that and do Ethernaut.owner to see. And we'll just add a wait here because it will return a promise. Let me just add those parentheses, and here we have the owner of the contract. So we can, this is how we can interact with this ABI here. ABI just contains the functions that we can call to see what the contract allows us to view. So let's get to it. Number 6 says get test ether. So to play the game, you'll need test ether. The easiest way to get some test net ether is via a valid faucet or a chosen network. Once you see some coins in your balance, move on to the next step. So let me show you my MetaMask here. I already have some Sepolia testnet, Sepolia ETH right here, as you can see. But if you don't have that, you can just go into Google Console. Gives people some test ETH. Let me see, Google Console Sepolia. We'll be using Sepolia ETH for this. So it should yeah, we have this here. You can just come here, click this, and it will give you yeah, you come here, paste your wallet address here, then you click receive Sepolia ETH to get the Sepolia ETH. And actually we can just do this right now. Let's grab our wallet address, then we receive this Sepolia ETH. So I'll paste it here, click receive 0.05 ether. Then here it says the testnet tokens are on the way. This may take a few moments. So we have this. Then let's check here. And as you can see, it was 0.03 and it has just changed right now to 0.827. So you can use this cloud.google to get you your Sepolia testnet Sepolia ETH for this particular CTF. So I'll just close that. I'll leave the link down in the description to get your Sepolia ETH. So let's continue. Getting a level instance. When playing a level, you don't interact directly with the Ethernaut contract. Instead, you ask it to generate a level instance for you. To do so, click the Get New Instance button at the bottom of the page. Go to it now and come back. So let's just get here, Get New Instance. And this will prompt MetaMask to open this dialog box here, and we need to confirm this transaction. As you can see here, it's a transaction to deploy this particular instance. So we'll just hit confirm there. Then it's loading. Then here we should have now the instance address. Now this is the instance address that we've just you can see here. We have this also confirmed transaction right here. So let's get back here. You should be prompted by MetaMask to authorize the transaction, which we have already done. To do so, you should see some messages in the console. Note that this note that this is deploying a new contract in the blockchain and might take a few seconds. So please be patient when requesting new level instances. We've gone through that, and you can see our console here. MetaMask is acting weird, but that's okay. So you're back here. Let's get to now number 7 here. So where are we? Okay, get destiny. Okay, we've done that. Number 7, then get new instance. Okay, we've done that. So now number 8, inspecting the contract. Just as you did with the Ethernaut contract, you can inspect the contract's ABI through the console using the contract variable. So let's just do that. Let's do contract and see what it has. So over here we have this information here, and what you want to keep out, look out for is this ABI. So ABI, as I've told you earlier on, it's application binary interface, which gives us it's like a language that allows us to communicate with the deployed Solidity contract. So here, as you can see, it has different information. This is just a constructor. Then here we have these functions. Over here we have authenticate, get cleared info, as you can see, info2, info42, info num, method, password, then the method name. So as I told you, we'll use Foundry to interact with this ABI to see what this contract has in order for us to solve this challenge, as opposed to how they're saying here that we need to interact with the browser console to solve this challenge. So all this that you're seeing here to do contract.info and these all these other functions here, we'll do this via scripting in Foundry. So I'll just click here to show you a few things here. This is the first function that we have here, and it's called, the function name is authenticate, and it takes an input. As you can see, the input name is a passkey, a string. This will be important for us when you're writing the interface of to interact with this particular ABI. So let me show you this next function over here. It's called get cleared, and it gives an output. As you can see here, it's a view. These are the state mutabilities. It's a view. These this is non-payable. Okay. Then we have the third function here. It's called info. Then it also gives outputs, a string. Then here we have the mutability. It's a pure function, so meaning it doesn't do make any changes in the chain. This view just means that it only reads from the chain, doesn't also make any changes. So let's continue here. We have, you can just click on these drop downs to view all these functions right here to get more information about them, but I'm going to use these informations right here to write our interface to interact with this contracts ABI. I hope that is clear. So let me get back to my virtual machine, because in order for you to run Foundry, you basically need to, Foundry only works in I think Mac environments and Linux environments, so you need to have WSL or run a virtual machine. There I'm running a virtual machine over here, and I leave a link to downloading installing Foundry, and also a video that shows you how to install Foundry from the Cypherin updraft course from Patrick Alpha C. He does a good job in explaining that. So while I'm here, I'll just click on the terminal. Then we'll start with creating a folder with Foundry. Then we'll get to writing the scripts. So right here, I'll just let me cd into desktop here. Then I have a file called Ethereum. So I'll just add directory I'm in. Then inside here, what we'll do, we'll run the command forge init. Then we'll call it hello Ethernaut. So this forge init initializes a Foundry directory, which will come packed with all the tools that we need in order to run Foundry applications, to run and build Foundry applications. So I'll just do that. As you can see here, it is downloading, cloning all the tools that we need. Then I think now it's done. So the next thing we need to do is just we need to now that we now have this directory here. Actually, you can just do ls to check. Here it is. Now you can use VS Code or whatever editor you're using, code editor that you're using. I'm going to use VS Code, so I'm just going to open it with VS Code with that command right there. And this should now open VS Code with this. Okay, I did a mistake. I should have done cd into this directory first. So VS Code will open, but with the wrong directory. I'll just close that. So here we need to cd into hello. Then now we need to do, that. Now VS Code will now open this particular directory, and we'll just start writing the interface and continue with the rest. So here, as you see, this is the directory that the forge init has created for us. It has all the tools that you need. So here we'll just go right into this source directory. Yes, I trust the authors, of course. Then here, actually what we need to do, just delete this one. I'm going to delete that one. Move to trash, we don't need it. Then here the script, also have the script to run that one. I'll delete that one too. Okay, now in this we don't mind that one. What happened? Where did the source directory go to? Come on, let me do Control Z. Oh, we deleted the wrong. Oh, we shouldn't delete the directory. We just need to delete this script. This is what I meant to delete. So I'll just delete that. Move to trash. Then now let's come here. We'll now create the file for the interface that needs to interact with the contracts API. So we'll just do then it's a level 0. So it's this is just the name of this CTF right here. Where is it here? As you can see, this is the level 0 one, just the basic one. Then you have level 1, so I'll just call it level 0. So it's nothing cryptic. So here I'll just do level 0 .sol. .sol is the file extension for Solidity. So the I just means that this is an interface. So right here I'll just start right off with the license identifier, the SPADEX. Then we'll go into do a Pragma Solidity. So that's the Solidity version that we're going to use. Then now we need to define the interface. So just use the keyword interface over here. Interface, then the name should be same as the name of the file. So let's just give it I level 0. Okay, so here we have this is how you write the interface using this interface keyword. So now let's come back here to write all these functions here, all these functions, and we just need to write them without the implementation. I'll just show you that. So first we'll do, let's say, let's start with the first one here. Close these drop downs. I'm going to check all these function names and write them. So let me just close these drop downs. Yeah, from this function number one. So first we have the authenticate one. So I'll just come here. Authenticate. Let me do a space there. So authenticate. And now for the states, if you come here and check, where was that? Here we have these states here, we have these states here. So yeah, we'll that's how we'll check the states for these different functions. So yeah, so let me go back to my virtual machine. For the function authenticate, if you check the ABI, it checks a string, which is called data. It was named passkey. All this you can see from the ABI. Let me just show you this. I don't want you to think that I'm just getting the words automatically. You can see here it's a passkey. This is the function name over here. So yeah, it takes that's what it takes here, passkey, and it's an external function. So external, yeah. Then this is the delimiter over there. So we're going to go to the next function. Over here we have this get cleared, then we have info 1, info 2 over there. So what I'll do, I'll just do something like, let me just write this one, info. We have info, then it was, if you read the contacts ABI, you'll see all this information. External pure, then this should return a string that will be saved in the memory. So that's that. And the next function, there was there's another function, info 1. If you check the ABI in the browser console, you'll see all this. So this is also an external function. That's how we are allowed to call it. Then here we have the correct information. Yeah, it's an external returns. Yeah, same thing. Then I'm going to write another function over here, info 2. Yeah, it's an external pure returns. Yeah, that's correct. I'll just hit tab. Then function. The next function should be an info num. This returns a uint 256. Then that's just an unsigned integer. Then the next function you have is this info 42, and again all this you can get from the ABI. Let's see what this returns before we just fill in anything here. It is info 42 right here. This outputs a string. So yeah, that outputs a string. So let's get back here, and let's say it returns a string to be stored in the memory. And now we'll go to the next function. Should be the method name, pure returns string stored in the memory. That's okay. Then next function should be password. Pure just means that it doesn't change anything in the blockchain. Just it doesn't make any changes. So yeah. Then the final one should be okay. We have authenticate over there, so I guess we're okay. But I'll just write this well. Authenticate. So I guess I have all of the functions here. So this is we've now written the interface. But the next thing you need to do, okay, first you do Control S to save this file over here. Now it's saved. Then initially you saw here it had a white dot, and if you save it now you'll get this X button over here. So after it's saved, now we need to write a script to deploy this function. And for the script name, I'll just do level 0 solution. Then I'll do .s. This is a convention when writing scripts. .s.sol. So okay, let me just edit this. I've written, let me add L here. So here we need to write a script that will help us to use the interface to interact with the ABI and the functions that are already deployed on this instance contract. Can I show you this real quick? This instance contract. So that is what we'll do here. So the same thing we did, we'll just do SPDX. So yeah, just then we'll define it. It's a contract level 0 solution. That's okay. We don't need that one. So before this, we need to import a few things. So one of the things we'll import is a script. Let me just do for just TD. Then I'll be importing script.sol. This one here. I hope it's okay. Then the next import that I'll make is we'll import this interface because we're going to use it. So why is this giving us a red squiggly line? Not found, file not found, searching by locations, not found. Let me see. This should be correct. I think the editor is just hanging, this being a virtual, yeah, it was correct. This was just hanging because this is a virtual machine. But yeah, this is correct. This is how we import them. So this let me just run you through this. This script.sol is Foundry standard library for writing deployment or interaction scripts. So it gives you access to VM cheat codes that we'll need to use to deploy this instance of to interact with this instance of the contract. So yeah, we'll be using it to simulate transaction, and it will also provide us with things such as console.log to log the results of our call or something. So yeah, let's just get to this. So okay, here we've already described that. Then I'll just inherit from this script. So I'll just do his script right there real quick. We are now inheriting from this here. Now we have the functions that this script has, such as the vm dot something something or console.log. They're all in this script.sol. So now what we need to do, we now need to, let me just first write this, then I'll explain. I level 0. What I basically have here is I'm trying to create an instance of the level 0 contract deployed at the address that we had here, this address here, in order for us to interact with it. So this basically says let me first grab this address over here. And let's just paste it there. So what this basically says is that hey, at this address over here, there's a contract that matches this interface, this eye-level interface, and I want to call its functions. So basically this is what this means. Go here and grab the contract that matches this interface that we've written here. Then we'll now use it to we'll use that to interact with it. So now the next thing that we'll do is write our run function. This is where the Foundry scripts will be injected. So we just tab that, and I'll do away with this. So basically here the run this run function is just the entry point of the Foundry scripts. So inside here we'll do a vm dot start broadcast, and this vm dot start broadcast kind of starts deploying the transactions that we'll make or something of the sort. So yeah, that's just that. So right here, what we'll now be doing here, we'll call the functions that we've already described in the interface. So we'll just log them here. So I'll just do console.log. We'll do all of these. Let me take you back here. It's hanging. We'll call all these functions to see what they have. So I'll just do console.log. Then let me just hit tab. Okay, my AI is doing the job for me. So I think here we have them, but do you have them? Well, what's happening here? Let me see. I guess I'll just do that. And so here basically we have all the functions that we wrote over here in the interface that we're trying to interact with. So here we're just trying to console log to see what the contract exposes at these different functions. So right here, this variable now has now gotten the information concerning this particular contract that is at this instance. So as you can see here, I'm trying to console log with the level, this here, level 0.info for the first function that we had, then level 0 for info 1, all the way to all these functions over here. And at this point we are done with writing our making the calls to these functions to see what they have. And after we are done, let's go here and then do vm.stop broadcast. You tell Foundry at this point just stop the broadcast. So yeah, so I guess that's it. Now that we are done writing everything, we can just go. Let's go to the terminal. Okay, I'll just do control backtick. We open the terminal and try to do a dry run, a simulation, to see what this gives us. So I'll just do, to run the script, just do forge script. Then you specify the file path to the script. So this is at level 0. solution .s.sol. So let's run that. So this is going to spin up Foundry's Anvil virtual machine, or an example of a virtual machine. Then it's going to tell us if this if there's any problem with it. Let's see here. Okay, I think everything is cool here, just that this contract is not deployed yet. So at this point, what we'll need is the private key and the Sepolia URL. So to do this, we'll first let me show you what we'll do here. We'll go to dashboard.alchemy.com, then just sign up for this. Then after you sign up, you'll have this dashboard such as mine. Then you go to create new app right here. Then at this point, we'll just call ours level 0. Then just paste that one there. Then our use case is just for analytics. You need this in order to deploy the transaction to the Sepolia chain. So here I'll just select Ethereum, then I'll go to next. Then just leave these as they're selected. There are 4 services selected. Then click create app. Then this will give you the Sepolia URL API key over here. As you can see, we have it here. Then before this, let's just select it to Sepolia so that it's on this Sepolia testnet. Then we'll come back here, and at the root of this folder, we'll create a .env file for these URLs. Remember, you shouldn't be exposing these API keys, but I'll delete this one after using it, so there's no need to hide it from you guys. I'll just do Sepolia underscore URL. Okay, wait. There is an issue here. Okay, sorry, we don't need the API key. Sorry. We don't need the API key, but we need the network URL in order for us to deploy it to Sepolia. So yeah, there was a miscommunication there, but just grab this, not the API key. So Sepolia URL, then just paste it here, Control V. Then the next thing that we'll need is the private key. So for this one, you'll go into your MetaMask wallet here. Then you'll grab it from here. So this will be the private key associated with your account. So what you'll need to do here is go here, then go to account details. Then here you'll go to private key. Then you'll put your password. So here, as you can see, we have this. It tells you hold to reveal your private key. So you'll just hold this. So I won't show you my private key here, but you just hold this. Then the private key that will be exposed, copy it, then paste it to your private key here, over here. Just paste it right here. So I'll just go and copy mine. So let me just remind you that when you are pasting your private key here, make sure it starts with 0x. So this way, 0x, then no x in lowercase. Then you paste the private key after this. So OX, then paste the private key after this. So do that, then we'll go to the next step. So at this point, I'm assuming you've already pasted the Sepolia URL and you have your private key well pasted. Then the next thing that you'll do is run source .env to make those environment variables available in this terminal. So just run that. Then after you run that, you can just do echo. Let me just do echo, let's say the URL, the Sepolia URL. That one I can expose. Sepolia underscore URL. It's not showing. Just a minute. Okay, I know what I've not done yet. If you can see here, you'll see here at this Sepolia file, you have this tiny white dot over here. It means I haven't saved it. So first, after you paste the Sepolia URL and the private key, just make sure that you do Control S so that it actually saves. So I'll just do that, then I'll come back. We run this source.env. Then if you do this echo, it will be successful. So just go and do that. So I've already done that, and as you can see here, we no longer have the dot here, means that it's now saved. The .env file is now saved. So if we again try to run the source.env, now we have the variables, the environment variables in here. Then if I do this echo sepolia.url, we can now see our URL. And if you do the same, if you do echo, then $ private key, you'll also see your private key right here. So let's continue. So after doing this, we can now just try to now deploy our script with the Sepolia URL and the private key here. And this is the command to deploy the script. So as you can see, you do -- as rpc URL, then you write the Sepolia URL, then you do -- private key, then you write the private key over here. Minus the broadcast. We'll come to the broadcast later. So let's just run this one. As you can see, it's compiling. Let's give it a minute. So here we have an error. Let's see what's the error. You will find what you need in for one, then you'll find okay, this is successful. Then let's go to the next one and try in for 2, but with the hello as a parameter. Then it reverts at this point here at info 2. So okay, what's happening here? Let me check the interface. So actually we did nothing wrong, we're just getting more information here. So here at info 2, what we need to do is add this hello as a parameter here. So I'll just come here and add the string hello. So yeah, we've added that. Then it's just hello. Then let's do Control S to save this file now. Then let's run it again to see. So it's running. Okay, expected 1 argument, but 1 argument given, but expected 0. So okay, let's go back to our interface here. The problem is in our interface here at this info 2. This should be taking a string data. I think doing the tab, this should be taking a parameter which is stored in the call data. Yeah, that way. So I think hitting the tabs really wasted us on that one, but that's okay. So let's just string data, call data. Then let's do Control S. Then we run the function. So as you can see, it says compiler run successful. So yeah, let's just check to see here. So script ran successfully, compiler ran successful. So here let's see the logs that we have. That's the call the console.log has logged for us. So info one says you'll find what you need in info. This info function, this one here, says that you will find what you need in info one. So info one says try info two, but with hello as a parameter. Then info two, the property info num holds the number as the next info method to call. Then we have info num 42. Then if you call that, it says, okay, let's see, the method name is the name of the next method. Then the method name is this here. Okay, then we have here the password is Ethernaut. So this is the password that you need to solve this CTF. What we'll go next to do is just ignore this red squiggly line, and now you can see it's not there anymore. So yeah, that's cool. Okay, so what we'll do here, let's now let's use this particular password to authenticate. We never used authenticate here. Why was that so? Okay, because okay, I understand the authenticate. Let me show you the authenticate here. Let's just go back to here. Now let's use this authenticate function, and where is let me close these other ones. Let me close this 01, and let me close this one and this one, so that you can have a clear view. So this where is it? This authenticate function takes an argument which is a string, and it's a passkey. So let's try to authenticate with the password that you've already gotten. So I'll just go back here. Then just below this console.logs, let me just say finally authenticate, after reading all that information and getting the information. So finally authenticate. Then we'll have a string. It will be stored in the memory, string memory. Then let's call it password, or let's just call it pass. Then that one will be gotten from this here, this call here. So I'll just do level 0 dot password so this should store this the password that we've gotten here in this variable. Then we'll now use the authenticate function to let me just hit tab here. We'll again call this contract, then call it with this function and pass this password that we've gotten from this call here, this function call from the contract here. So let's run that again and see what we get here. So we'll just still run it the same way, and we'll see what it tells us here. Okay, we've not saved it yet. I keep on forgetting that we have this white dot over here. So I don't know what Forge will give us, but let's see. But just know that we haven't saved it here. So actually, I don't think it will. Yeah, it doesn't give us any different information. So let's just hit Ctrl S. Then let's save. Then it should now appear saved here. Ctrl S. Yeah, now it's saved, and also, as you can note, it's now reformatted. Then let's just hit the up arrow. Then let's run it again. Now we should see that it simulates a transaction that the way it will be made in this Sepolia testnet. So let's wait on that. So as you can see here, simulation complete. So let me just drag this up here. So yeah, it was simulating, it was doing a dry run, and is showing us the estimated the chain ID, the estimated gas price, and what will be the amount that will be required for us to deploy this script on the spoiler testnet chain. So yeah, so as you can see here, simulation complete. To broadcast these transactions, add broadcast, this dash broadcast on this command that we had. So we'll just now add, let me just scroll here. Now to this command that we have, we'll just add dash broadcast so that we can now let me first do this. So now at this point, what we were doing without the dash broadcast was just trying to do a simulation of to see what we'll get when we do now the real execution. The real execution is with this dash broadcast. So this is the real execution, and this now means that the contract is going to interact. The contract interactions are going to be broadcasted to the spoiler testnet, and is now going to be included in the blocks. Yeah, so I hope that is well understood. So let's just run this. So when you run this here, after it's done, it should now be able to solve the CTF. Now we went through a lot of process here, but this is just because we're just starting out and we are trying to set up different things. And let's see what we have here. So yeah, as you can see here, it's sending the transactions over here. This is now making the real execution. This is no longer a simulation. This is the real execution. And let's give it time. So as you can see here, on chain execution complete and successful. Let me scroll up. So yeah, as you can see here, it has successfully deployed the script here. As you can see, this the match ETH that we paid, and we have our block number over here paid to spoiler testnet, and now this shows us that this script has been successfully deployed, and this password has been authenticated. We've used the password to authenticate, and now at this point we should go back to here. We should go back here, and when we scroll down here, if we do submit instance, it should now accept that we've completed this CTF. So let me just scroll down here, then you'll see it from here. Actually, what I can do, let me just clear the terminal first so that you see it well. So I'll just click submit instance. It's telling us to please wait, and MetaMask will pop up here and we'll confirm the transaction. Then we'll see that we've completed this particular CTF. So here, let's just confirm the transaction. So let's wait for it. And as you can see now, we are getting this. Well done, you have completed this level. We are getting all this here. And when you complete the level, what will happen is that now the code for the contract will now be revealed to you. So this is the code that we are working with. As you can see here, we have everything here nice and neat. We have the constructor, then the different functions that we were calling here, and what they were returning. All this, you will find what you need information in info 1, then try info 2, all the way here. So yeah, these are the functions that we were using the ABI to interact with. These are already deployed at the spoiler chain. So yeah, so again, we've gone through a lot of process here, but most of it was just configuring what we'll need for Foundry and all the other things. But these are simple beginner level CTF. This is level 0 actually, and going on with the proceeding with the other CTFs will now be going a little bit faster. But yeah, that was the Hello Ethernaut CTF by Open Zeppelin's Ethernaut. And yeah, I'll see you in the next CTF of this Ethernaut. The next one will be fallback. So yeah, the next one we'll go to in the next video will be fallback, and I'll see you in the next video.